Hello, I am Dr. Viviapara, Senior Scientist in Soil Science and Agriculture Chemistry, working at Central Horticulture Research Station, Vejalpur, Panchmahals, Gujarat. This is the substation of CIH, Central Institute for Air Horticulture, Bikaner. In this presentation, I want to explain about Dris, Diagnosis Recommendation Integrated System, and what is Dris, how to calculate Dris indices, how to calculate Dris norms, and how to interpret these Dris indices for fertilizer recommendation. This is the main theme of this presentation. Dris, Diagnosis Recommendation Integrated System, Dris. Dris employs a survey technique where a large number of randomly distributed sites throughout the area are selected. At each site, samples of leaf and soils are taken for analysis and the details of applied menus and fertilizers are recorded. Experiments also conducted at one place, employing various levels of 1, 2 or 3 plant nutrients can also be used to develop Dris, taking the following steps. During the survey, population is divided into two subpopulations, that is low yielding and high yielding, with a cutoff value. Individual nutrient concentration derived from high yielding population are used to classify into deficient, low, optimum, high and toxic based on standard deviation SD. The nutrient concentration in the range with mean plus or minus 4/3 SD are optimum. Less than mean minus 8/3 SD are deficient. Mean minus 8/3 SD to mean minus 4/3 SD are low. In higher side, mean plus 4/3 SD to mean plus 8/3 SD are high, and more than mean plus 8/3 SD are toxic. If you observe the normal distribution curve, we can easily observe all these things. This is the normal distribution curve. Population was expressed in form of normal distribution curve. Here you can see mu. Mu means average of the population. This is sigma, indicates standard deviation. This is plus side, this is minus side. Here one is plus sigma, plus 2 sigma, means this sigma indicates standard deviation. Right side more than average, population belonging to more than average, and left side minus side means the population belong to less than average. So all the population should come into normal distribution form. Here we can confirm the population plus or minus standard deviation, total population around the mean should be 68%. Total almost all 95% population should come within plus or minus standard deviation. 95% population should be attained in this form. So this normal distribution, after attaining normal distribution form, we divide the population into optimum, low, high, toxic, deficient. Different groups we divide the nutrients, different nutrients we express. We should confirm the population by chi-square test whether these belong to the groups frequency belongs to normal distribution or not. We should confirm with chi-square test. Generally, this chi-square test will be done to know whether the observed population and expected population are same or not. we expect some population, some percent population, but whether the observed population belongs to the same as expected population, the percentage. To test validity of these things, we do chi-square test. Here, this chi-square test, how to do this chi-square test? Here we take observed population in one column and expected population in one column, and we calculate the difference in one column and we scale it. Then this difference scale, observed and expected population difference scale by expected population will give some ratio. We should add up the cumulative of all the observations on the percentage groups that we expected and observed group difference in their ratio by scaling and dividing by expected population. That factor comes, that factor we should add up, and cumulative of that value is only the x-scale, chi-scale value. This chi-scale value should be less than the table value. Then it indicates non-significant, means that there is no difference between observed population and expected population. That means expected and observed population are same. Means if there is no difference between expected and observed population, means chi-square value should be less than the table value of the at 5%. It should be non-significant. If it is difference is significant, there is a difference between observed population and expected population. So this chi-square test is used to differentiate between observed population and expected. Whether the observed population and expected population are same or not. To test this, we use this chi-square test. These are the nutrient norms of amla. For nitrogen, phosphorus, potassium, calcium, magnesium, sulfur, iron, manganese, zinc and copper. Total 10 nutrients. 6 macronutrients, 4 micronutrients. Macronutrients are expressed in percentage and micronutrients are expressed in ppm. These nutrients are classified into 5 major categories. The middle one is optimum, right side high and excess, and left side low and deficient. These nutrients are classified based on standard deviation. Mean plus or minus 4/3 SD belongs to optimum population, and more than mean, more than 4/3 SD belongs to high population, and mean plus greater than mean plus more than 8/3 SD belongs to excess. In left side, low population belongs to more than mean minus less than mean minus 4/3 SD, and deficient less than mean minus 8/3 SD. Standard deviation, these are the classification based on standard deviation. This is the table representing the nutrient norms of Sapota for macro and micronutrients. These nutrient norms are developed from high yielding population of leaf samples of some Sapota. Here in leaf sample, 10th leaf is selected as a leaf sample from top. These nutrients are classified according to standard deviation only. Previously I told phenomena, how I selected, I classified the samples, deficient, low, optimum, high and toxic. These are the nutrients. For 10 nutrients I developed the nutrient norms: nitrogen, phosphorus, potassium, calcium, magnesium, sulfur, iron, manganese, zinc and copper. Macronutrients: nitrogen, phosphorus, potassium, calcium, magnesium, sulfur. These macronutrients are expressed in percentage, and iron, manganese, zinc and copper are expressed in ppm. These optimum nutrients: suppose nitrogen 1.252, 2.38, phosphorus 0.052, 0.17, potassium 0.362, 0.77, calcium 1.012, 2.04, magnesium 0.48 to 0.92, sulfur 0.38 to 0.82, iron 18.92, 147.43 ppm, manganese 18.12 to 36.97 ppm, zinc 7.89 to 16.57 ppm, copper 3.9 to 5.6 ppm. These are the nutrients I got for optimum nutrient concentration. These will be utilized. These mid values, optimum mid values are these optimum nutrients are utilized for developing the Dris indices. If we get the nutrient concentration in this optimum range, generally the crop is well supplied with these nutrients, and according to these nutrients we can see the Dris indices. We can develop the Dris indices. The developing Dris indices is separate part from the nutrient norms. In development of Dris indices, when A by B, capital A by capital B, matlab ratio of nutrients in the plant to be diagnosed is more than A by B. A by B means small a by small b, matlab standard value developed from Dris norms. The sample value A by B is compared to the norm value small a by b by division. If the balance of the A by B is optimum in a plant sample, then A by B by A by B equals 1. Thus, capital A by capital B by small a by small b minus 1, and consequently function of capital A by capital B equal to 0. If capital A by capital B, that means the nutrient ratio of the sample is greater than the norm means standard value small a by small b, then capital A by capital B by small b minus 1, and if function A by B are positive numbers, means if the ratio of the sample is greater than the norm ratio of the norm, then the indices become positive numbers. Finally, if the ratio capital A by capital B means sample ratio is less than the norm, the equation will be negative. This is what I want to speak about these indices. Calculating Dris indices. For hypothetical nutrients A through N, A index is function of A by B plus function of A by C plus function of A by D, like that up to function of A by N by Z. Z is the total number of nutrients. Next, B index is equal to minus function of A by B plus function of B by C plus function of B by D, like that function of up to B by N by Z. Z is the total number of nutrients. Next, N index is equal to minus function of A by N minus function of B by N minus function of C by N minus function of by M by N by Z, where A by B, capital A by B is the nutrient ratio of the sample, small a by small b is equal to nutrient ratio of standard value developed from this. Therefore, function a by b is equal to a by b means the corresponding nutrient what we are diagnosing is equal to a by b. A by b मतलब the nutrient ratio under diagnosis by standard a by b minus 1 into 100 by coefficient of 1000 by coefficient of variation. If when a by b means the nutrient ratio of diagnosing plant is less than a by b means standard value, ratio of standard value, then the function is function of a by b, capital A capital B is equal to 1 minus ratio of a by b of the standards by divided by ratio of the diagnostic nutrient a by b into 1000 by coefficient of variation.